To statistics, this is the first lesson. Can Joy smell Parkinson's disease? This lesson kind of is an overview and encompasses all of what you'll be learning this year in statistics. Basically, it starts with a hypothesis that nobody really thinks that you can smell Parkinson's. That's a common belief that we haven't really even thought about or even been tested until Joy Milne has tested this particular idea. So this particular lesson starts out with a video showing Joy actually explaining how she actually thought she could smell Parkinson's. Bottom line, she was smelling this strange odor on her husband. It was not a good odor, and she thought he just wasn't showering enough and wasn't getting clean. However, then as it went on, she was in the research science field, and she started noticing the same smell over Parkinson's patients. And so then she spoke up and told the research scientist, why don't we investigate the smell of Parkinson's? So she explained her situation, and they went ahead and tested her claim by giving her a bunch of t-shirts that had people that wore Parkinson's and people that did not wear Parkinson's. Half of them people had Parkinson's and were diagnosed with it, and half of them people were not diagnosed with Parkinson's. And they put them in separate bags and randomly shook them up and took them and gave them to her, and she was able to identify all but one of them correct. One of them, she said, had Parkinson's, and they said that they have not. So at that point, I asked the students to go ahead and answer these questions. And it's important for question number 1 to know if you can smell Parkinson's, because it would be helpful for early detection and also prevention. If you had on number 2, 6 correct decisions, that would be about, if I was guessing, because 6 out of 12, 50-50. We did have some evidence, number 3, that Joy could smell Parkinson's because she could smell 11 out of 12, and that is greater than 6. So we do have some evidence. The question is it enough evidence? And that's what we're going to be testing today. And finally, number 4, this is a personal question. Some people thought, if someone got 9 out of 12, I'd be convinced, 10, and so forth and so on, someone got all of them. And some people said, no, I'd never be convinced. I think it was just a hoax and someone was making something up. So what we did is we investigated to see if we actually could smell Parkinson's, and what we decided to do is get 12 shirts, and the 12 shirts, 6 of them said Parkinson's and 6 of them said no Parkinson's. We put them in a pile, shuffled them up. One person had the cards and smelt the cards and showed the other person the other side, and they would guess if it said yes or no. And this represented, when I did it, I smelled 12 shirts and got 7 correct and 5 incorrect, and my partner told me what I got right and wrong after I was finished. This here I had 25 students do, and I had 25 people, and this was the results that we got. Each dot represented the correct guesses from one simulation of the experiment. This is what you would have gotten by guessing. So then I went ahead and graphed what Joy got, and if you notice, 0% of the time did Joy's result happen by guessing, by chance, because what we got in our blue graph here, the blue dots, represent what we would have gotten if we just guessed on the Parkinson's experiment. And so we compared Joy's results to what we would have gotten just by chance, being lucky by guessing. And we found that 0% of the time would she have gotten the same results. So that's really significant, because we're saying if 0% of the time she would have gotten what she got by chance, 100% of the time she would have done because it was actual skill. So yes, based on our experiment, based on our simulation, we do have some significant convincing evidence that Joy can smell Parkinson's. So here's our notes. LT starts 1 is learning target 1 and LT2 is learning target 2. So for the first one, we notice in our particular experiment, individuals are the person or thing being described in the set of data. And the variable is any attribute for the individual that varies. We have 2 types of variables that we'll be talking about, and that's what it shows. We have categorical variables and we have quantitative variables. Categorical variables are exactly that, variables that can be put into a category. So if I have the categories of Skittles, I've got red, the category of red, yellow, blue, green, those are categories. The categories, but quantitative would be numbers, like what's your height, what's your weight. Category variables make sense when you find an average. Categorical variables, it doesn't make sense to find the average of red and yellow. If I have, I have 7 red Skittles and 4 yellow Skittles, it doesn't make the sense to find the average of red and yellow. Frequency tables show the counts of data, and relative frequency tables show the percent. So I'm going to go ahead and show you a little bit what I'm talking about here. Let's look at this table. And on this table, it says identify the individuals and variables in the set. Remember, individuals is the person or thing that's being described. It says on the second day of a statistics course, the instructor gave 40 students in the class a survey. The table shows the data from the first 10 students on the class roster. Identify the individuals and variables in this data set. Classify each variable as categorical or quantitative. So the individuals are the 40 students in the statistics course. Categorical variable is all of these different variables: sex, class, dominant hand, amount of homework last night, whether or not they have a smartphone. The quantitative variables have the other variables that have to do with numbers that make sense to add, subtract, multiply, divide. It's like GPA, pulse rate, number of children in the family, and amount of sleep. Because for GPA, it would make sense if I found the average GPA. So that's why they're quantitative. But for class, it wouldn't make sense if I said, hey, what's the average class? Well, I cannot find the average or add up the average of a junior and a senior and a sophomore. I can't do that. That doesn't make any sense. And the last part here is the ages of 40 students in the classroom are shown here. Summarize the distribution of age with a frequency table and a relative frequency table. So the frequency table is just this. I have 5 people that are 14, 4 that are 15, and so forth and so on. The relative frequency table is doing the percentage out of the total. So I had 5 people that are 14, 40 total people, 5 divided by 40 is 12.5%, and so forth. Thank you for listening, and I hope you have a wonderful day.